Well, hello, everybody. Welcome to chemistry and welcome to Lewis structures, which is day two in bonding. And today our goal is that we try to get through like what it's like to bond atoms and how to draw their Lewis structures. This week you'll be doing a molecular model lab. You'll be playing with the kits. You'll be creating stuff in Pearson. So this is a key skill, and I guarantee this will show up on May the 6th, which is our AP test. So just be ready for it. It's not that bad. Okay. So there are steps, and you'll practice all week, just like bonding stuff and just like that. Okay. So let's get started. So bonding. So there's different ways that things can bond. So atoms can bond like ionic, and that's just a transfer. Lewis structures are usually meant for when it's a covalent bond, when they're sharing electrons. So the steps, I'll just kind of show you guys these steps and we'll talk about them. First off, you're going to count valence. You're going to pick the center atom. You're going to bond all the atoms. And typically, what we do for a bond is we draw little lines. A line represents the sharing of two electrons or a covalent bond. And then everybody always has to have an octet until they don't when there's exceptions. We'll learn all those. And then you're going to count electrons and make sure they're equal. So at the end of this, if you have 28 electrons, you have to make sure that there are 28 electrons. And of all of the stuff in chemistry, there are the most exceptions for this one. There seems to be an exception just waiting around the corner, so you have to learn all the exceptions. Okay, so let's get started. Let's see if we can do this one. So we're going to do this, which is, let me change the view a little bit so it's a little bit bigger. We'll do it as a presenter view. Yeah. Way better, everybody. Way better now. Okay, so remember when you're bonding these things, what you're going to do is you have to always start by counting valence. Okay, so this doesn't appear to be working. Maybe this pen will work. Yeah, that pen works. Okay, so for example, in this one, what you have to do is you have to count how many valence the C has, which is 4. Now, the reason why it has 4 is it's in group 14, which they all have 4. So just remember, like the valence numbers based off of the electron configuration. And this is in group 17, so this has 7, but there's 4 of them, so that's 28. So 28 plus 4 is 32. So when we're done, you can only work with 32 electrons. And so what you're going to do is you pick the center atom. So everything is going to be bonded to C. Typically, you don't do this. You don't do Cl, Cl, like make long chains, because it's all stuff that's just bound around the C. Not, let me clear that. So we're going to put 32 electrons in their proper places. Let me see. I think I'm still good on this one. Yeah. Okay, so 32 electrons. So we're going to start in the middle and we're going to bond everything. Okay. So we're going to give everybody a bond. And so carbon typically will have 4 bonds. And so it has 8 electrons in its outer shell, 2, 4, 6, 8. What's happening is they're each sharing an electron. So this is the bonded structure. Now you can't forget to put in what we call the unshared pairs. These are unbonding pairs or non-bonding pairs. So they're important to the structure. So this is the part about everybody gets an octet. Okay, and after you're done, you just count. So if everything is completed, their outer shells, if they all have 8, you're good. So we know that this is 8 right here, 8, 8, and 8. So 8 times 4 is 32. That's my good structure. Okay, let's do this one. So when you're doing this, what you're going to do is the S is going to go in the center. H will never ever be a center atom. And the reason why H can't is it can only have one bond. So when you start building them, you're going to just always use the white pieces, which are H, and you'll figure that out as you go. So you're going to have H, S, and H. Okay, so you bond everything. The S goes in the middle because it's farthest from F. And then you need a total of, let's see, this would be 2 plus 6. So you need a total of 8 electrons. You notice that 8 is like a common theme here because the octet rule. So you're going to give everybody an unshared pair. And then H is good. H does not need 8. So I had a kid one time do it this way and I made fun of them. Okay, don't get made fun of by Mr. Wood. Okay, this is not going to happen, right? For several reasons. First, right, this can't have more than 2 because it's the 1s. So it's the only atom that really just in helium that needs 2 electrons to fill their outer shell. All right, let me clear this one. All right, let's do this last one here. So we have 4, we have 3, and we have 7. So this is the valence numbers. You just look at the group on the periodic chart. We've already talked about this. So this is going to have a total of 14 when it's done. So the one that goes, one that goes in the middle is C. So it's going to be C and Cl and H and H. And it really doesn't matter where you put them because in three-dimensional space, they're just going to be put wherever. And then everybody gets 8. And if you count 2, 4, 6, 8, 10, 12, 14, it equals the 14 number here. And so this is a correct Lewis structure where it just shows like the bonding and how it's all oriented around there. Okay, so let me clear the selected thing. We're going to go back here. Okay, so now a couple key terms. So when you're bonding stuff, you're going to have to look out for like an unshared pair. So an unshared pair, this is something such as like you have O with H, and I'm going to just draw it out so it looks like this. So this is an unshared pair, and these are bonding pairs, and the valence electrons are just the ones involved in bonding. And the Lewis dot structure is just, it shows how everything's bonded together. Okay, so this is super important. When you get to it, this is what they're looking for. Okay, now what I want to do is take a moment, and we're going to just, this is a worksheet that you'll have, and you just want to fill it out. Okay, so as you're going to do this, maybe just take a moment and fill those out or pause the video and try this. But what you're going to do, all right, is you first have to figure out how many valence it has. And so it's all about this. So that F has 7. So you're going to put 7 valence electrons around it. Okay, and I don't really care where you put them. Typically what they do is they put them in pairs. And honestly, the College Board doesn't care either, unless they tell you, which there's a chart and you can just follow the chart. It's super easy. Okay, look at oxygen. Oxygen is group 16, so it has 6. So it's going to go 1, 2, 3, 4, 5, 6. And it's going to have an unpaired, there's room for it to bond there. Okay. K is going to have 1, so it's going to look like this. Al3, so it's going to be Al3. Okay, and again, typically when you put them in, you put like 1, 2, 3, 4, 5, 6, 7, 8. But again, I don't care. All right. So now if it's an ion, you gained an electron. So this has 8. So this is why it becomes an ion, to gain an octet. So it's going to have a complete filled shell. And this whole group, if you look at this, this is all filled up. The one I want to mention is K. K looks like this. So they typically will put polyatomic or monatomic ions in brackets with the charge on the outside. So technically it looks like that. Okay, but this one doesn't have anything around it because it lost its last shell. So typically if you lose it, it's considered empty for that. Okay, so let me go here. All right, now the ones I want you to try, let me go back here and then move up. So these bottom two, these are simple Lewis structures. So take a moment and just do that. So for example, for this one, this would be 7 times 2 or 14. So you would bond everything. And when you count, you don't have to do any like shenanigans here. You just like put them together and that's it. So try these and then check my key and make sure you're good. Whoops, I misspelled check. Check key. Okay. So before we go on to the next level, just take a moment and maybe just practice to make sure and then double check with the key that you can do simple ones. Again, sometimes chem's like so easy, it's hard. You're like, wait, it's all it is. You just put a couple sticks together and put some dots around it. And that's exactly what it is. Okay. And it does get a little tricky. All right. So let me clear this. Let's talk about double and triple bonds. So in the event that you, dear students, do not have the matching value. So for example, in this case, what you need is you need 4 and you need 6. Okay, so this is the valence electrons. This is the group number. So group Si is in silicon, it's in group 14. And O is in oxygen, it's in group 16, and it has 6. So I need 10. Okay, so you still do the same thing. So Si is going to be my center atom. So we're going to bond these together. And then everybody gets 8. And then you count. Okay. And when you count, you're going to find out this is 2, 4, 6, 8, 10, 12, 14. So 14, anytime that you are over this number, that means you need to add double or triple bonds. Okay, so you use the valence electron stuff to count to see how many electrons you need to add. So let me show you guys what you do to add. So everybody still has to have 8. So you're going to put a double bond in. But now when I put the unshared pairs in, I'm only putting 2, 4, 6, 8. Do you see how I have to reduce the number down? I can't put like 3 unshared pairs around there because I'd be over 8. All right, so this one's bad. So now I have 2, 4, 6, 8, 10, 12. That's the number of valence electrons if I count here, 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 here. And so do you see by adding a double bond, I go down by 2. So I need to be at 10. So I guess what I have to add? I have to add a triple bond. So I'm going to add a triple bond here. And now I can only put 2 electron pairs, unshared pairs around it because look, we have 1, 2, 3, 4. So that's 8 electrons. And if we count this 2, 4, 6, 8, 10, we have our magic number. And so when I draw this out, I'm going to draw it over here. It's Si. I'm going to draw Si with a triple bond. and then an unshared pair on there. And that is the correct drawing. Okay, so when you're doing double or triple bonds, you still have to do the same thing. The trick is if the numbers don't match, then you know, oh my gosh, I have to do that. Okay, so let me show you another one if I can. Wait, go back. All right, so we'll come back to here. Let me go over here. We're going to go to the back of this. Okay, so pause the video for a second. And well, wait, let me do the first one, then pause it. Okay, so let me go here. We're going to go down here. We'll go here, clear selection. All right, there we go. Back. All right, so now we're going to go down. All right, so these are the ones. So hold off on this, hold off on this section, which is like the exceptions. I want you guys to do this section right here, which is this is the multiple bonds one. Okay, so right here. All right, so we're going to put it in here. So first off, you have to look up what C is, and C is 4, but there's 2. So it's going to be 4 times 2, which is 8, plus 4 is 12. So our magic number is going to be 12. So you bond everything. So we're going to put the C's in the middle because C is always in the middle. And then you're going to bond H's, okay? And then when you bond these H's, you're going to then give everybody an octet except H. So you're going to put an extra pair here. Okay, so then we count 2, 4, 6, 8, 10, 12, 14. I'm 2 over, everybody. I'm 2 over. So what you need to do is you need to, let me see. My face is gone. I got to see if I can, I don't know why. Okay. For some reason, it took my face off. Maybe it's still in the video, but I don't know. It'll just be the voice of Steve in the background. Okay, so anyways, what I'm going to have to do is I'm going to have to get rid of these unshared pairs and put a double bond in. So we're going to get rid of those. And there's a double bond that goes here. And if you count 2, 4, 6, 8, 10, 12, it works out. Okay, so a really good one to show you guys, and one that's really common, and so you'll do these in just a second. So is CO2. So C has 4 and O has 6, but there's 2 of them. So this is 16. So you're going to bond everything. So we're going to put an O in between there. Everybody gets 8. So sometimes what they'll do is they'll just put double lines like this. Each line represents 2 electrons. So this is for lazy people. Some people hate that, but that's just what you do. And when you count this, you'll find out it's 2, 4, 6, 8, 10, 12, 14, 16, 18. It's 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And 20 is too much. In fact, it's 4 too much. Okay, so what we know is if it's 2 too much, let's erase all this here, then it's a double bond. If it's 4 too much, it's usually a triple bond, but in this case, it's 2 double bonds. Okay, so we're going to have a C here, double bonded, another one here, and then you're going to put your unshared pairs. And then when you're done, what should happen is everything should have 8 electrons, and it should work out. So this is now 16, and it's good. Okay, so you're going to take a second and do this, and then check the key, which is online. Okay, so everybody pause what you're doing and try that. All right, so back to this, and let's see. Wonder if I can get my picture up. I guess not. Yeah, it's sharing my screen, but it doesn't matter. My face is ugly anyways. Okay, now sometimes what you're going to get is you are going to get a weird one. Okay, so formal charge is used to determine if the structure is valid. Okay, so for example, you can have this cool structure, and I'll just give you a couple options. So you can either have, let's do this one. It can be so for this one, it's a polyatomic ion. Actually, I should probably do that first. So I'm going to skip back. I'll come back to this one. Let me go down to the next one. Back. I'm going to do polyatomic ions first, and then I'll go explain this one. All right, so for a polyatomic ion, what's going to happen is you still count it up the same. So it's going to be, let me go back up. Shoot. Got to be better. All right, so here we go. So for polyatomic ion, this is 5, right? And this is 6 times 4, so that's 24. So I'm at 29. And then the charge is you add that, this 3 extra electrons. So this is plus 3. So you add all that up, that equals 32. All right, so you're going to put the P in the middle, and then you're going to put 4 O's around. And then you're going to give everybody 8. And again, if you don't like drawing, you can draw lines like this, and then put it in brackets to show that it's an ion with the charge on the outside. And you'll find out that this one is 32 when you do it, and so it is correct. So now when I go to this side over here, let's go back here. Let's clear the selection. Let's go here. So you're going to, oops, go back. We're going to go up here. Okay, so polyatomic ions. So when you do these ones, you're going to try these real quick. So you're going to pause the video, or you can do this afterwards, and you'll check your work on the key to make sure you're okay. Okay, but for this one, what you're going to do is, so for CN, you have 4, you have 5. So that's the group numbers are in plus 1. So we're looking at 10. So C bonded to an N, and then everybody gets 8. I know these are small, so you'll have to like smoosh them in. Okay, and then you're going to put them around brackets just like this with a charge on it. And you're going to find out that this is at 2, 4, 6, 8, 10, 12, 14. So I'm 4 over, so I'm going to need a triple bond. So let me clear the screen. I'll start this over again. So C bonded with the triple bond, boom, boom, in brackets, boom, boom, and you are got 10. So when you do this, they should always equal the same number. Voila, people, voila. Okay, so take a moment and do that, and then I'm going to talk about formal charge, everybody, formal charge. Okay, so let me clear the selection, get back, and then let's go back up to formal charge. So in formal charge, what happens is this is a way to determine if your structure is correct. The College Board loves formal charge, loves it so much. It's so great. Okay, so we're going to draw, I'll show you guys 2 options for this, and this is you have to pick the best one. Okay, so you have N with a triple bond and a C in the middle and S. And so this should have 5, 4, 6, so that's 10. Let's see, 9, so 15. So this should have 16. Okay, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 2, 4, 6, 8, 10, 12, 14, 16. So this one is correct, okay? Or you could do N with a double bonded, and you could pick, it could look like this. Okay, so for this one, what the question is which is a better one? Should I put the triple bond on the end, or should I put 2 double bonds in? And the way you do this is you take this valence electrons minus assigned. So assigned, for every single bond, you assign 1 atom. And for every unpaired electron, it counts as 2. So for example, in this one over here, and you do this per atom. So N should have a valence number of 5. And it has 5 valence electrons assigned. Do you see these 2 unshared pairs right there, and then 3 bonds? So this would have a formal charge of 0. 0 is good. You always want to have zeros all across, or you want to have something as close to 0 as possible. Okay, so when we look at that C has a valence number of 4, and it actually has 4 signs. So you're going to do 4 minus 4, which would be 0. So far, this is looking good. And then what you want is you want to do S. So S should have 6. It actually has 7, so it's minus 1. So that's not good. Okay, so you want it to be 0. If it's not 0, it kind of has to make sense. We'll explain what that means in a second. Okay, we're going to go back over here, and we're going to do the same for this other structure. So you always do valence minus assigned. So this is going to be 5 minus 6. Do you guys see how we have 2, 4, and then each bond counts as 1, so 6 around there. So this is minus 1. And then this would be, again, 4 minus 4, which would be 0. And then this one would be 6 minus 6. If you take a look, we have 2, 4, 6. So 0. So one of these is better. Okay, so what we want is we want the most negative one to be assigned to the most electronegative atom. And so you have to look at the chart and you find out that N is more electronegative. So this structure is actually better. You want all zeros, or you want a negative charge to be on the most electronegative element. So you're going to see that a lot when you see these things and when they start explaining about where that's from. Okay. All right. So I'm going to clear the selection. We're going to go back. We're going to wrap these notes up. So back on your sheet, when you make it, double check. Most of these only have 1 valence electron, but you just never know. So if they have multiple, then you would do your formal charge for that. Now I want to end with the thing about resonance. Okay. So resonance is when you can have multiple Lewis structures. And what I mean by that is like right here, this structure is for O3. So let me put this in here for a pen. So O3 has 18. Okay. So you're going to put O and another O, and then you're going to bond it. You're going to find out when you bond it that one of these will have a double bond. Okay. So when you draw it, it's going to look like this. Okay. So this double bond could be here, right? Or it could be here. And so what resonance says is, when they first discovered this, they said that the bond resonates. So if I was there, I'd ask my music kids if they know what resonance is in terms of musical instruments. But basically they thought it vibrates. It vibrates between these two, and it's constantly this. Well, experimental evidence actually found that it's actually not vibrating between the two. It's just like a blend of the two. So this technically is a 1.5 bond, not a double bond here, because it's an average of the two. So regardless, you'll notice resonance. Resonance will be only with double bonds, and it can only be if that double bond could be in a different location. Okay, so you'll see a lot of this, and yeah, it's super cool. Okay, so let me go back here. All right, so I'm going to save the expanded octet and a few other exceptions. What I want you guys to do is I want you guys to try this, this little chart thing here, this magic. See if you can figure these out, and then double check on my key on Schoology just to make sure you're getting it. Wait, cancel. Okay. And then you're going to want to try to do the Pearson on this one. We're going to do a molecular model kit, which is more practice on this. It may be good to see and build them with that as well. Okay, I'm going to end this train wreck of a video as best I can. So hopefully this helps. If not, we'll find a way, people. We always find a way. All right.